Lost Arkyves presents Unexplained Magnetic Signatures. What Mars sample return might reveal about Martian geology's secrets. Imagine, if you will, the surface of Mars. Not the dusty, red desert we've come to know, but a planet once teeming with volcanic activity, a world with a dynamic, shifting crust. For decades, we've seen hints of this ancient power in the strange magnetic patterns etched into the Martian bedrock. These aren't just random quirks. They're the ghosts of a planetary dynamo, a lost magnetic field that once shielded Mars from the harsh solar winds. Think of Earth's magnetic field, that invisible bubble that protects us. Mars had something similar, billions of years ago. And when it vanished, the planet began to change dramatically. But the remnants of its ancient magnetic field are still there, locked away in the very rocks that make up the Martian surface. These are known as magnetic anomalies, vast swaths of crust that are either strongly magnetized or curiously devoid of it. And they're not uniform. They form these incredible, complex patterns like a giant, ancient fingerprint left by the planet itself. What's truly fascinating is how these magnetic signatures are preserved. When molten rock erupts from Mars' interior, as it did on a grand scale in its early history, it cools in the presence of a magnetic field. This process essentially locks in the magnetic orientation of the minerals within the rock, creating a permanent record. But over time, these ancient magnetic patterns have been disrupted, altered, and sculpted by geological forces we're only beginning to understand. We see stripes, swirls, and even what look like giant magnetic bubbles in the crust. Now, the Mars sample return mission. This isn't just about bringing back rocks, it's about bringing back answers. When scientists get their hands on these carefully collected Martian samples, these magnetic signatures will be a Rosetta Stone for understanding Mars's deep geological past. By meticulously analyzing the magnetic properties of these samples in Earth-based laboratories, we can reconstruct the strength and structure of Mars's ancient magnetic field with unprecedented detail. Did the magnetic field die suddenly, or fade away gradually? What role did geological processes play in its demise? These magnetic signatures hold the clues. They can tell us about the very heart of Mars, its molten core, its internal heat, and how its geological evolution differed from Earth's. Were there periods of intense volcanic activity that influenced the magnetic field? Did certain mineral compositions in the crust amplify or diminish these magnetic signals? The data we've gathered from orbit has been incredible, painting a broad picture of these anomalies. But to truly decipher their meaning, to understand the why behind these magnetic mysteries, we need to hold those rocks in our hands. We need to study them up close, to unlock the secrets they've held for eons, frozen in time within their magnetic orientation. Mars sample return is our best chance to finally read this ancient magnetic language and rewrite our understanding of the red planet's fiery, dynamic history. The geological secrets locked within these magnetic signatures are waiting to be revealed.